So here we have a cube. Much like squares have a lot of special properties because they have all the same side lengths, cubes do as well. You can go ahead and try to calculate the the space diagonal for this cube if you want to pause the video and try that. So I'm going to calculate it, but I'm going to calculate it a very specific way because I'd like you to try to notice a pattern. So here, if we wanted to calculate the space diagonal, we know now it's length squared plus width squared plus height squared equals the diagonal squared. Here, all of these lengths, widths, and heights are the same. They're all 5. So that's 5 squared plus 5 squared plus 5 squared equals the diagonal squared. So instead of doing the exponents and adding them, I'm going to treat this almost like a variable. I have 3 5 squared. I have 3 times 5 squared is equal to the diagonal squared. And then I'm going to take the square root of both sides. Okay, if I take the square root of both sides, the square root of something squared, that is just giving us the diagonal. 3 is not a perfect square, so it'll stay under the radical. The square root of 5 squared, that's the square root of 25, which is 5 root 3. So notice here, if instead of 5, I had s for side, we could treat this like a variable. Let's say it was an s for side. It would work out the same way. Side squared plus side squared plus side squared would be 3 times side squared. And the square root of side squared is the side length times the square root of 3. So what does this mean? This means that for any cube, you just take the side length and multiply it times the square root of 3. There's a pattern with this, as a matter of fact. So go ahead and copy this in your notebook. Notice that the diagonals for squares is the side length times the square root of 2. Again, here we see those dimensions again. A square is 2-dimensional. It has those 2 dimensions, and so it's whatever the side length is times the square root of 2. While the cube is 3 dimensions, so for a cube, it's whatever the side length is times the square root of 3. So this is as simple as, let's say that my cube side length here was not s, but it was 10. So now I know that the length of the space diagonal in this prism is 10 times the square root of 3. My goodness, I'm really having a lot of trouble here. 10 times, there we go, 10 times the square root of 3. If this side length here for this square was instead 3, this side length would be 3 times the square root of 2. And this is for all squares and all cubes.